This is another learning session of remainder, and this is the third video where we go through variety of examples that related to remainders. And today in this video we move forward to some complex example, and if you have any doubt in this session you can write down to us in the comment block. Otherwise, if you are having any personal doubt, you can also share that doubt with us. We try to give you the same explanation. Okay, so don't forget to subscribe this channel. Let us start this video. Today I'll give you an example. Let us suppose the question is 81 to the power 82 divided by 17. And in this case, what will be the remainder? Okay, so here we have to find out the remainder. Now 81, if you try to go very close to 81, when the divisor is 17, we know that 17 5s are 85. Okay, so let us start from there. So when 81 is divided by 17, if you take 17 5s are 85, then the remainder is 85 minus 81 minus 4. Okay, so here the negative remainder we are having minus 4 to the power 82 divided by 17. But if you multiply minus for 82 times, obviously that will give you the result of plus. Okay, so there is no need to write down minus there if the power is even, because here the power is even, it is 82. Okay, now in the next case 4. Now the power thing is 4. We take some n of 4, so that should be very close to 70. So it is 4 squares are 16. So let us take that one. So here we can write this one as 4 square to the power 41 divided by 17. Okay, now 4 square means 16. That can be written as 16. So 16 to the power 41 divided by 17. 16 to the power 41 means 16 into 16 into 16 into 16 up to 41 times. Now, every time when we divide 16 with 17, when we divide 16 with 17, the remainder is what? Minus 1. So here minus 1, again minus 1, again minus 1, again minus 1, minus 1 up to 41 times. So result is what? Minus 1 to the power 41. So here we are having minus 1 to the power 41 divided by 17, or that equals to minus 1 divided by 17, or the final result. This is the real remainder, minus 1, but remainder is always expressed in the form of positive, plus. So final remainder is 17 minus 1, that equals to 16. This is your answer. Okay, now in the next question we'll go through. The question is, what is the remainder when 7 to the power 32 divided by 1000? Okay, so here the question is 7 to the power 32 divided by 1000. Now divided by 1000 means we need the value for the last 3 digits. So whatever the value of 7 to the power 32, if you find out the last 3 digits, then that one is the remainder in this case. But how to find out the last 3? In our previous video, we go through how to find out the unit digit, the last 2 digits, or the last 3 digits. Okay. And if you don't view that video, the link is given here. You go through this link and watch that video. but I'll describe now how to find out the last three again. So this 7 to the power 32 can be written as 7 to the power 4 whole to the power 8. 7 to the power 32. Now 7 to the power 4, 7 squares are 49. Now 49 squares are 49 square means if you take 50 as the base, then this is less only 0 1. 0 1 square 0 1. 49 minus 1, 48 divided by 2, 2401. It is quite easy. You can find out mentally. If you practice little bit or if you go through that video, you can find out by yourself. Okay. Now, so here we are having 2401 to the power 8 divided by 1000. Now, this 2401 again can be expressed in the form 2400 plus 1. Now, so this can be written as 2400 plus 1 whole to the power 8. By using that binomial expansion method, we can find out the last three very easily. This is in the form of a plus b to the power 8. So if you try to find out a plus b to the power 8, that can be expressed in the form of a to the power 8, 8c1, a to the power 7, b to the power 1, 8c2, a to the power 6, b to the power 3, and so on, so on. And finally, that will end at b to the power 8. Okay, I just write down the same. Here we can write 2400 to the power 8, then 8c1, 2400 to the power 7 into 1 to the power 1, and so on, so on. Finally, that would end with 1 to the power 8. Just the previous one is 8c7, 2400 to the power 1 and 1 to the power 7. Okay. So, if we are having 2400 to the power 2 in this case, the results having 4 number of zeros, and any number having 4 number of zeros easily divided by 1000. So we don't need to find out the values. Only the need is just the last two. These two we have to find out. Now, in the last two, now 8c7 that equals to 8c1 or that equals to 8. So here we are getting 8. Now 2400. Now simply 1, then plus 1. This part belongs to this. This belongs to this. Now, but here, if you multiply 8 into 2400, 8 into 4, 3200. Finally, that will give you 200 plus 1. You can multiply the whole, but there is no need because we need the last three. Okay, so here, let us suppose I'll multiply. This is 16,000, this is 3,200. So finally 19,200 plus 1. So this is 19,201 divided by 1,000. All previous terms completely divisible by 1,000. Okay, so 19,200 divided by 1,000. 19,000 divisible by 1,000. So remainder is what? 201. So finally, remainder we are having 201. This is your answer. Okay. Now, the next one. In the next example, we are having find the remainder when 5 to the power 90 is divided by 187. Okay, so the question is 5 to the power 80 divided by 187. So if you consider the power of 5, 5 to the power 2, 5 to the power 3, so on, so on. So 5 to the power 3 equals to 125. But here the divisor is 187. there is a huge gap. It is difficult to find out. So in this case, we go through some other techniques or some theorems that related to this that will help you to find out it easily. Okay, now this 187 can be represented as 11 into 17. 187 equals to 11 into 17. Okay, now as per the theorem, we know that whenever any number a to the power p minus 1 when divided by p, the remainder is always 1. Here a is considered as any number and p is considered as a prime number. Okay, so a to the power p minus 1 divided by p, remainder is always 1. Here we'll apply that one. How? This 5 to the power 80 we divided in two phases. One is when divided by 11 and second one is when divided by 17. If in both the cases the remainder is constant, then that one is the final remainder. Okay, how? So let us suppose 5 to the power 80 divided by 11. We know that 11 is prime. A for any number, you can consider anything. So 5 to the power 80 divided by 11. 5 to the power 80 can be expressed in the form of 5 to the power 11 minus 1 into 8. So this one is 5 to the power 11 minus 1. This is considered your p minus 1. Now again to the power something, or you can multiply here 8 also. So this is in this form, 5 to the power p minus 1 divided by p. Okay, so in this case, remainder is what? 1. Now the second part. In the second part, we are having 5 to the power 80 divided by 17. Apply the same again. So this is 5 to the power 17 minus 1 into 5 divided by 17. 17 is also prime and this is in the form of a to the power p minus 1. So here in this case, remainder is 1. So when we are having in both the cases remainder is 1, final remainder is 1. This is quite easy to find out. Okay, now let us try for the another example. Okay, now the question is, find the remainder when 459, 459, 459 up to 900 digits is divided by 999, 999. So in this question, we are having 459, 459, 459 in a repeated manner, and total we are having 900 digits. And this whole is divided by 999, 999. Now, here 459 repeated continuously for up to 900 digits. Every time we are repeating 3. So there are 300 pairs of 459. 459, 459, 459, 459 up to 300 pairs. Total 900 digits. Now divided by 999. This particular number, this bigger number, can be expressed in a different form. How it is? The first one is 459. We are having 900 minus 3 means 900 minus 3 means 897 zeros. Now, in the second case, 459, 894 zeros. In the third case, 459, 891 zeros. And so on, so on, so on, so on, so on. If you write down this one in 300 parameters, first one, second one, third one, fourth one, fifth one, sixth one, and so on, so on. And if you add all, finally you will get this one. 459, 897 zeros, 459, 894 zeros, 459, 891 zeros. And the final one is simply we are having 459 without any zero. Or the previous one is 459 only 000. Or the previous one is 459 000 000. So we are adding all to get this one. Now, this whole part divided by 999. This 459 000 or 459 000 000 or whatever that may be, always can be expressed in the form of 459 into 1000 to the power n. That n may be 1, 2, 3, 4, 5, 6. Now, 1000 divided by 999. So when 1000 divided by 999, remainder is 1. 1 to the power anything that equals to 1. So every time, in all the cases, we are having 459 as the remainder, every time. And here we are having 300 cases. Okay. So, how we will find out that 459, 300 cases divided by 999. Okay. 459 into 300, result is what? 1200, 150, 1350 plus 27. 13,770 divided by 999. We can solve this one in a different manner also. Either you simply divide it to get the result, or how you divide it? The 137,000 plus 700. I'll write down here. 137,000 plus 700. This whole divided by 999. Now, every time here we are having 1 as remainder. So that will create, or this one can be written in the form of divided by 999. Here we are having 1 remainder, so that will give you 137, and here we are having 700. So final remainder is what? 837. This is your answer. Very simple. There is no need to find out the through divisibility test. We can simply find out in this way also. Okay. Now, in the next video, we go through some more complex examples. Those examples that make you master in remainders. So wait and watch that one. Thank you for watching this video.